what is signal? Signal is defined, which is a function which conveys information from one place to other place. Signal defined as a function which conveys information from one place to other place. So there are basically two types of signals. Continuous time signal and discrete time signal. Continuous time signal, shortly I am writing as CT. So hereafter CT represents continuous time signal. So and DT. Basically the signals are classified into two types. So continuous time signal and discrete time signal. So what is continuous time signal? How to define the continuous time signal? So the continuous time signal which is defined, so for this continuous time signal, the amplitude exists for all values of time t. So I am representing the continuous time signal amplitude x of t, or the signal I am writing as x of t. So x of t exists for all values of time t. So the time value which may be a fractional value or integer. X of t exists for all values of time t. So this is continuous time signal. So example, sin t, cos t. Example for continuous time signal, sin t, cos t, these are all continuous time signal. That means see here I am drawing the sine wave form. So this is the x-axis is time axis and y-axis is x of t. Since x of t is equals to sin t. So x of t is the y-axis and x-axis is time axis. So the sine waveform, the sine waveform exists for all values of time. The amplitudes for all values of time t, it exists. This is a sine continuous time signal. So whereas discrete time signal dt, shortly I am writing as dt, so which is discrete time signal. So which is notated with x of n. X is a variable and x of n is the discrete time signal. So the discrete time signal exists only at discrete instance of time, not for all values of time. So here the time represents small n. The discrete time signal exists only at discrete instance of time. Discrete instance of time. So x of n exists only discrete instance of time. So what is the meaning of discrete? So discrete nothing but integers. Discrete is nothing but integers. So x of n exists only for integer values of time. So time here I am noting as n, small n. Here for continuous time signal, the time is small t, here small n. For a discrete time signal, here it is small n. So time axis is n here and y-axis is x of n. So this class just fundamentals I am doing. So this is the signal. X of n is equals to the signal I am giving, just for example. So the n is positive or negative integer. So the amplitude which may be a fractional or integer, but the time is x-axis values are all are integers only. The discrete instance of time is the time value. Here the time is n. So n is always integers, positive or negative integers, but x of n amplitude which may be fractional value or integer value. So here the discrete time signal is defined. So this is graphically I am given the discrete time signal. So what is the value here? X of 0. When n is equals to 0, x of 0, what is the amplitude? 1. When n is equals to 1, x of 1, what is the amplitude in the figure? When n is equals to x of 2, it is 1.5. So here it is given 1.5. and x of minus 1, 0.5. So for remaining values of n, it is the amplitude is 0. That means it's not given. So that it's not given means it means the n value is 0. The amplitude is 0. Okay, here the signal is exist. The x of n have non-zero values between n is equals to minus 1 and minus 1 to 2. Generally, the range of n is equals to minus infinity to infinity. Minus infinity to plus infinity. Same here also, the t range is equal to minus infinity to plus infinity. For a continuous time signal, the t time range is minus infinite to infinite. For a discrete time signal, small n range is minus infinite to infinite. But the given example, in this given example, the n value is lies between only minus 1 to 2, minus 1, 0, 1, 2. For the remaining values of n, the amplitude is 0. So this is one way. So other way of writing x of n is equal to 0.5, 1, 1.5. They will give graphical form or each sample. This is nothing but one sample. These are one sample. Each sample like this they will give, or in the form of brackets they will give. So here arrow indicating. So here arrow indicates means at n is equals to 0. At n is equals to 0, x of n is 1. The right side of arrow are positive values. The left side of the arrow is negative values. This is discrete time signal. Any doubt in continuous and discrete time? Hello? Yeah, if you have any doubt, you can interrupt. Can you increase your volume?
Hello? Sir?
If you have any doubts, you can interrupt.
No doubt, sir.
So basically the continuous signals are classified into types: continuous time signal, discrete time signal. Continuous time signal, amplitude exists for all values of time t, whereas discrete time signal, the amplitude exists only discrete instance of time. Operations on signals. Operations. First I will discuss continuous time signal. Then I will go for discrete time signal. Operations on signal. The first operation, amplitude scaling. First operation, amplitude scaling. So here the given signal, I am naming given signal is x of t. X of t is the given signal. So amplitude scaling. So I am multiplying constant with x of t, where x is the amplitude, where x is the constant. So the resultant I am naming in y of t signal. Y of t is equals to c into x of t. So x of t is the given signal. X of t is the given signal. Y of t is equals to c into x of t. So y of t is nothing but amplitude scaled version of the given signal x of t. So this is amplitude scaling. So when you perform amplitude scaling operation for any signal, for a given continuous time signal, the only amplitude changes. When you multiply the given signal with the constant, only the amplitude changes, not time axis. Second operation, time scaling. When you perform amplitude operation, only amplitude changes, not time axis. So now here time scaling. So time scaling, when you perform time scaling operation, only time axis values changes, not amplitude. Suppose x of t is the given signal. X of t is the given signal. Then x of a into t, where a is the constant. X of a into t. The resultant I am naming in y of t. X of at is the time scaling signal. So how to draw x of at? Suppose when a is greater than 1, when a is greater than 1, then how to draw x of at? So compress x of t signal when a is greater than 1, compress x of t signal by a times. Okay. So compress x of t signal by a times. Then you will get x of at. How to draw x of at? When a is greater than 1, compress x of t signal by a times. When a is lies between 0 and 1, when a is lies between 0 and 1, so how to draw x of at signal? So now expand x of t signal, by a times. So you'll see example on operations. First I will explaining all what is time scaling, what is amplitude scaling. Then we'll see problems on time scaling. X of t is the given signal, continuous time signal. So y of t, how to draw y of t, which is x of at. So based on the a value, so x of at we are drawing. So when a is greater than 1, so compress the x of t signal by a times. Then you will get x of at. When a is lies between 0 to 1, expand the signal x of t signal by a times. Then you will get x of t. Operation time shifting. Next operation time shifting. So x of t is the given signal. X of t is the given signal, and so x of t minus t naught. How to draw x of t minus t naught? This is the given signal. X of t minus t naught, where t naught is the time shift. The resultant signal I am naming as y of t. X of t is the given signal. So x of t minus t naught we have to draw. That is the given. So based on the t naught value, if t naught is greater than 0, the t naught is constant. The t naught is time shift is constant. If t naught is greater than 0, then how to draw x of t minus t naught? Shift x of t signal towards right by t naught times. Shift x of t signal, right by t naught times. If t naught is less than 0, the same thing, how to draw x of t minus t naught? Shift x of t signal towards left by t naught time. The remaining thing is shift x of t signal towards left by t naught times. Fourth operation, reflection or time reversal. The first operation is amplitude operation. The 3, 4 operations are time reflection or time reversal. So x of t is the given signal. X of t is the given signal. Then how to draw x of minus t? How to draw x of minus t? The resultant I am giving in y of t. So how to draw x of minus t? X of t is the given signal. How to draw x of minus t? So x of minus t is nothing but the reflected version of x of t about amplitude axis. About amplitude axis. Not time axis, about amplitude axis. So place the mirror on the amplitude axis and whatever the signal waveform is there in the right side, draw it in the left side. The left side waveform, draw it in the right side. So that is reflection or time reversal. These are some examples. So these are the operations on amplitude and time operation. See, among 2, 3, 4, suppose in a problem x of at plus b. See, all the 3 operations on time comes in this one problem. All the 3 operations we need to perform in this single problem. So x of a into t plus b. So t plus b is time shifting. A into t is time scaling. I am placing here minus also. Then reflection. So all the 3 operations. X of minus at plus b. So the question comes here, which operation we need to perform first? Among the 3 operations on time scaling, time shifting, time reversal. So which operation we need to perform first? So always perform first. The precedence rule tells always perform first time shifting. The next 2 operations, anyone you can follow, but the first operation always perform time shifting. Among the 3 operations, the first operation always perform time shifting. So which is x of t plus b. So first we need to perform time shifting. So x of t plus b, where b is the shifting towards left by. So compare now x of t minus t naught. What is t naught now? T naught is equals to minus b, which is less than 0. So shift x of t signal towards left by b times. The second operation we can do any one, either reversal or time scaling, any one. So I am doing time reversal, x of minus t plus b. X of minus t plus b. And third operation, time scaling, x of minus at plus b. Or you can do like this also. The second you do time scaling, that is x of at plus b. X of at plus b. Then third you do x of minus at plus b, time reversal. So both answers same only, but always perform first operation is time shifting.